Okay. So I bet you've all heard incidents regarding cross-chain bridges and mixers. So the biggest hack involves cross-chain bridges because that's where the assets are aggregated. And mixer is an important topic because mixer allows malicious actor or hackers or even some sanctioned entities to mix their coins and to make it difficult for law enforcement to trace. Now first, let's introduce cross-chain bridge, and then we're going to talk about cross-chain bridge validation model, and then finally we'll talk about mixer. So what is cross-chain bridge? Different blockchains are very separated. They have they use different language. They have different nodes, and they have different protocols. It's very difficult to to transfer one asset to another without introduction of a central entity such as a CX exchange. And with the demand of data processing increased, Ethereum network is not enough to run all the smart contracts and meet all the business logic. So we have other blockchain projects with lower costs and shorter confirmation times, such as Solana, Avalanche, Cardano, and Cosmos. They have seized this opportunity to get an explosion in growth when users moving their crypto assets from Ethereum to other blockchains. However, due to the incompatibility of data from different blockchains, many types of crypto assets are in isolation and difficult to interact with each other, which brings inconvenience to users, especially when the number of blockchain protocols is increasing and asset interactions are becoming more frequent. There's an urgent need for a new type of technology to enable interactions between different blockchains. That's when bridges come into picture.
Excuse me?
Yeah.
Is there a good resource to be able to get an understanding of how these new different blockchains rank against each other, perhaps in the number of users or the amount of nodes or the amount of value in cryptocurrencies? Is there any kind of ranking system?
I would say that before it's called like Misari.io, and also CoinMarketCap is a good resource.
Which one, sorry?
CoinMarketCap.
CoinMarketCap.
Yeah, and maybe they changed the address, but the previous address was Misari.io. That is like MESSARI.
Okay.
Yeah. So they actually do some research in terms of the different chains in terms of user activity and different nodes and different like TVL, like the project's volume. Yeah. Also, if you're interested in DeFi, you can maybe check out the Dex.guru. Dex.guru.
Yeah. DEX.
GURU.
Okay.
Yeah.
Okay, cool.
And if you don't trust their data source, because it might be complicated and it might be out of date, yeah. I suggest you to check out this Dune.xyz.
June.
DUNE.
Yeah.
.xyz.
All right.
So basically, you can create your own custom queries, and they have some already made queries that you can just run them and get real-time data on every single project that you're interested in. And you can create a dashboard, a custom dashboard, and just put in different projects that you are interested in and have a really cool comparison.
Cool.
Yeah.
If you have time at some point today, will you show us that? Because that would be really useful to have a look at.
Yeah.
If you have time.
Yeah, for sure.
Awesome.
Yeah. So what are the cross-chain bridges? A cross-chain bridge is a connection to transfer crypto assets or data between blockchains. Two chains may have different protocols, rules, and governance models, and cross-chain bridges provide a compatible way to interoperate security before the two chains. And as we can see here is an example of cross-chain bridges. We can send in assets on Ethereum mainnet and get it to another network blockchain. There are many types of cross-chain bridges. First, there's a lock and mint. Lock assets on the source chain and mint synthetic tokens on the destination chain. So for example, if I want to bridge Ethereum to this Avalanche, then users first send in Ethereum to this contract owned by this bridge entity, and Ethereum is locked inside this, or Ethereum, or any assets on Ethereum, for example, USDC, is locked inside this contract. On the Avalanche side, this bridge entity will issue synthetic tokens. So for example, if users send Ethereum to this bridge's smart contract on the Ethereum end, then the bridge will issue wrapped synthetic ethers on the side of Avalanche. And users can use synthetic ether on the Avalanche side to trade other assets. So this finishes this entire circle of bridging. Of course, when user trying to withdraw, the assets will be locked on the other side. Unlocked on the other side and give it back to user. So this is by far the most common type of bridge. A good example is ERC20, which can represent any virtual assets on Ethereum, including Ether itself, which is represented by the WETH. Sorry. Yeah.
Can synthetic ether be converted to actual ether, or can synthetic ether be converted to fiat?
Synthetic ether, or if there's any exchange that accepts synthetic ether, then of course it can be converted to fiat directly.
Okay.
Yeah, but theoretically, synthetic ether can only be converted back to ether, because that is guaranteed by the locked assets backed by the bridge.
Okay. So in the case of synthetic ether, given that it's been minted, does that also contribute to the total available balance of, say, ether and Ethereum? Because assuming Ethereum has a maximum number of units, so do the synthetic ethers also contribute to that? Because we can't have infinite number of coins, right?
Yeah, of course. And that's one of the problems, because as maybe you have heard, the FTX actually did a lot of synthetic assets on the Solana side, and that is not fully backed by their reserve, and that's why, for example, the FTX issued BTC wrapped a synthetic BTC has no value basically. It's not pegged to BTC anymore. So when you issue synthetic asset, it is not included in the original chain, and that's why it's not limited by the market cap. As long as you say that you can fully back up your claim. For example, I've locked this assets on this smart contract, then I can issue the same amount on the other side of on other blockchains. But those assets have to remain locked. Yeah, it's like collateral.
Okay, so RAP itself has no value. It is backed by the
yes.
And the question is whether that locked token preserves its value or whether it drops in value.
Well, if the collateral went wrong, for example, if there's a hack in the vault, then those synthetic assets will be worthless. Yeah.
All right, thank you.
So, quick question: who builds these bridges and maintains them?
There are lots of bridges, and a lot of companies specialize in building bridges.
Okay, so is it normally like the, say, Avalanche today actually build the bridges themselves? They've got teams that build them, or is it like third parties that come in and build them?
Some projects have their own bridges. For example, the layer 2, for example, Optimism, they have their own bridge, and but for project build bridge, they will have more security in mind, and it might be inconvenient to use. For example, the lock period might be 7 days. Okay. But for third parties, they're trying to increase user experience and trying to be competitive, right? Yeah. And that's why they do this instantaneous exchange of assets. So most bridges are built by third parties.
But I assume it would be promoted by the blockchain.
Yeah.
Because for them it's good to be able to create these synthetic coins from bigger blockchains like Bitcoin or whatever. Commerce.
Yeah.
So they want that. They want the bridges to
Yes, they do want the bridge to be built on that has their blockchain included, because they can attract more users from other blockchains.
Of course.
Yeah.
Okay, I understand. But bottom line is like third parties that are creating these bridges, so you need to trust that third party. That
Yes.
securely.
Yes.
Okay.
Some of the lock contract is open source, so you can see that your assets actually there, and you can actually audit that the issued synthetic assets equals the locked assets.
Oh, you can see that.
Yeah, sometimes, but not all the times.
Okay.
Yeah.
So would exchanges like Binance build the bridge, like build the cross-chain bridge?
Binance built the bridge for themselves. For example, the BEP20 to the BSC smart chain. So they have two like BSC chains, and that's why they build bridges between their own product.
Oh.
Yeah. But the exchange itself is a bridge. For example, you can deposit BTC to exchange and sell it for ETH and then get to the ETH, right? It's just a centralized entity. And bridge is more decentralized. And there's also liquidity providers. The cross-chain bridge deploys the smart contract of the source chain on the target chain and transforms the target chain into a side chain of the source chain, enabling the transfer of information between the two sides. The project owner creates a liquidity pool on different chains, through which users can directly exchange native assets on the other chain. On the other hand, liquidity provider can provide tokens as liquidity funds in exchange for a portion of cross-chain transfer fees or APY revenue. So, liquidity pools are a common product in different chains. And when you have liquidity providers as this cross-chain bridge, then people can have the option to trade and bridge at the same time. For example, I can bridge my USDC from Ethereum to BSC, but I want to get USDT at the other end. Liquidity provider enables this function.
So it's correct to say that basically they are creating it's not a synthetic coin or token, they're creating a real token on the other chain. Is that how it works? So you've got one here, and then they create a real token on the other chain.
Yes.
Okay.
Yes.
And then how they hold it. So how do they make sure you don't double your money?
So basically, you exchange assets on one chain, and then they have liquidity pools on the other side that you can swap the assets.
Okay.
Yeah. So.
When you swap, you effectively give them control of something on one chain, and you get the equivalent on the other chain.
Yeah.
And you can do what you want, but if you want to get it back.
Yeah, because their asset, their token, when you send them to the contract, they'll get burned, right? So this ensures that there's no double spending.
Gotcha.
Yep. And there's atomic swap, which is a most advanced bridge. There's perhaps the most secure and trust minimizing method of transferring local assets to other chains, but it has some drawbacks. Both chains must share the same hash algorithm to ensure that blocks containing the transfer can be verified on both chains. So like for blockchains that share same hash algorithms, it's not always the case. And that's why atomic swaps are limited, even though they are advanced and secure. So this is a Polkadot specific protocol. Polkadot uses this relay parallel chain architecture to pass messages between two different homogeneous parallel chains using the XCMP model. That is Polkadot's cross-chain message passing protocol. This enables independent handling of cross-chain asset processing without the need for a third-party authentication. So if I have two parallel Polkadot chains, you can bridge assets freely using this protocol. Cross-chain bridge security is a hot topic. Because cross-chain bridge hold massive funds and are frequently attacked, the top three bridges in terms of liquidity have all undergone security incidents. Several cross-chain bridge attacks have been caused by private key compromise, such as the Ronin incident we talked yesterday, and authority management vulnerabilities. Also, there's a bug caused by a lack of legitimacy check of LP token, signature reuse signature reuse, etc. Yeah, signature reuse. An example would be the Binance bridge attack, and also the Harmony bridge that was a signature reuse because the verification system has some bugs in it, and basically it was an interesting story. It's like a decentralized robbery. So someone posted on a Discord community that just copy paste this signature and broadcast your transaction, you can get money. And so basically 100 people copy paste this transaction and they robbed this Harmony bridge together. But some of them return assets afterwards because they have their information like leaked or something. Or maybe they want to do white hat hacking instead.
I have a question.
Yeah.
On the cross-chain bridge, right? To clarify, is it an independent provider or is it done by the chain itself?
Sometimes it's an independent provider.
So it could be a third party, basically.
Yes, yes.
Then the next question is that what are the third party? Number one.
Yeah.
What's the difference between the one that is done by Ethereum versus a third party? Then the next question is who is accountable if something goes wrong?
Most bridge they have their companies, so the company will be accountable if something went wrong. But this industry is not that heavily regulated yet. So a lot of times when bridge incident happen, there's no way to actually find someone accountable. Yeah.
It's not defined.
It's not defined.
It's up
Yeah.
to you as a user.
Yeah,
to
of
pay.
course. Yeah.
And there's also breaches provided by the chain itself.
Yeah, there are bridges provided by chain itself.
So they are also third party. Which one is better?
I wouldn't say which one's better. It depends on the circumstances. And sometimes the bridge provided by the chain itself is not really usable. For example, the optimism one, you need a 7-day grace period. That you have to wait 7 days to withdraw your assets. Not many people want to wait that long.
Is there a third party to rank, like ranking which one is better in terms of security?
Not yet because yeah,
Nobody doing that.
nobody's doing that yet. Yeah,
Okay.
but you can start doing that, I think. Yeah.
Because
Cool.
I think it's value because
Yeah, for sure.
People doesn't know the technical
Yeah,
detail, right?
and the thing is, I think almost all of those bridges have suffered some kind of attacks. So yeah, it's kind of difficult to measure their competency. Yeah, but
Correct. I mean,
yeah.
in fact, most of us cannot. Maybe Beosin would be the kind of company with the competency to do so, right?
Yeah,
Because in a sense, your reputation, you're almost like an audit firm, right?
yeah. But if without we actually looking at the code itself, we cannot give like a full judgment on this project. So some of the project they've done auditing in other companies, so we haven't looked at their source code, and we cannot just say, oh, this is safe for sure. That's kind of irresponsible for our users, I think.
So it's a pretty wild west thing.
Yes, it is. Yeah. Also, that story was a Nomad bridge, not the Harmony. The Nomad bridge was the first decentralized robbery in history. So almost over 100 people participated in the hack incident.
Just
Yeah.
additional question in regard to the previous slide.
Yeah.
With Polkadot.
Yeah.
That's being created by the project itself. So does that mean that it's more secure?
It is very secure. It is very secure, but it only works in like Polkadot parallel chains. So if it's other chains, then you have to rely on other bridges.
Right.
Yeah.
But the Polkadot other chain could also create a bridge with another chain. Is that possible?
This is protocol specific that has to be like in the within like you have to implement certain Polkadot protocols that is only happening in the Polkadot parallel chains. So for other chains, for example, like EVM or Bitcoin, they use completely different structure, and that is impossible to actually use this method to bridge them.
So they have to use what, like the atomic or the lockmeat or the liquidity approach? Polkadot to non-Polkadot.
Yeah,
They can't use this one, right?
yeah, they can't.
Yeah, I understand. So this is just for two Polkadot parallel chains?
Yes.
So this is different from a liquidity and block mint and atomic swap, the
Yeah.
way that the
Yeah.
XCMP works, it's different.
Yeah, it's different. Yeah, it's different.
Polkadot.
Think
Yeah.
of Polkadot's specialty as a function of when they design the blockchain protocol,
It's their own
they
language,
built
right?
in this bridge.
Yeah.
Like it's like they are second one, right? So like
So Jasper,
Yeah.
would it be fair to say like, Polkadot, Infinity, they have a certain standard for cross-chain, right? I mean, the standardization is very obvious, whereas
Yeah.
where you do different,
Yeah.
from different other blockchains,
Yeah.
the standardization is not there, and that's
Yeah.
where all the
Yeah.
loopholes are.
Yeah.
Is that where then you have to be a lot more careful?
Yes.
Yeah. But how
Yeah.
many of you mentioned that the atomic transfer is probably one of the most secure, right?
Yeah, it is.
And you also going to do some on hash time lock as well.
Yeah. So there's limitations.
Yeah, the limitations and so on. What about notary scheme that people talk about? If you use another trusted third party, is that something that people use a lot? The notary scheme that you have another party to become, are they being used? Obviously not, right?
Oh, sorry.
The notary scheme.
Not,
Notary scheme where
No risk,
where
yeah.
there are very few people use that.
yes, very few people use that. And most bridges, they are kind of centralized. And even they claim that, for example, they use this, I remember this synthetic bridge, like the one who's issuing signatures is actually an EOA address, not even a smart contract. So it could even be me, like sitting behind a computer issuing like transaction signatures. So
This is very much nothing much to do with move or Rust
no,
security, but more
custodial security.
it's more where you are in some ways if you are out of chain, right?
Yeah.
Right. So if it's within blockchain as a node, in the case of Infinity,
Yeah.
it's a lot safer, right? Would you say that?
Some bridges, they are operated by nodes, right? And like Definity. So yes, they will be safer, but they are still, it's still difficult to value the security because, for example, the node's private key can get compromised, such as in a roaming attack, and sometimes the node will have they use this model that they would assume that everything is good intent, but someone can challenge this if a malicious transaction is found, and if the challenge went through, then the challenger can receive the reward. That would discourage the malicious transaction and award the good actor. So there are different models in terms of nodes and having this impact on security. For example, in the Binance case, they do have different nodes in terms of the bridge between this BSC to BEP20, but it only takes 100 BNB as a collateral to become a node, to participate in a node network. So the hacker actually paid 100 BNB and became a node, and therefore he can actually interact with networks.
So I mean, you're saying the proof of stake in some ways because you can just, in some way you can just stake
Buy
it,
out.
right? And
Yeah.
therefore you can control
Yeah.
the cross-chain. Are there any other methods similar to proof of work that is much harder for you to do that? I mean, you slow down, but
Yeah.
does it make sense?
Yeah, but proof of work, I think, would be it's relatively new in bridge because many like if you use proof of work model to build different nodes and use that for verification, then you have to, the security will entirely be on the signature part, because in the end you still need to receive events or signals from one blockchain and broadcast signatures on the other side, because you need a way to communicate with those two blockchains that you are trying to bridge. So those parts can still be vulnerable because you're going to have smart contract on both those chains and a node network separately. So yeah.
One last very basic question.
Yeah.
Is that much risk is in the communication protocol?
How much risk is in the communication
Because
protocol?
that is not decentralized at all.
Yeah, it's not. And
I mean, you can do all this,
Yeah.
work proof of stake.
yeah,
But a very basic question I want to ask you,
yeah.
especially not mostly cross-chain, a lot more communication, right? The
Yeah.
communication protocol, how risky is that?
It's risky. That's why you need cryptography secure signature verification scheme, because anyone can. I can broadcast my forged signature to the smart contract. It's a matter of they accept it or not. So the communication part is impossible to maintain that it's entirely closed. But if the cryptography is sound, then the signature will be checked out, and it's gonna be better in that sense. Yeah.
So it seems that the stake has to be much higher in order to ensure that the interest is aligned. You know, in all this.
Yes.
Yeah. Otherwise, it will be quite easily compromised.
Yes. Yeah. Sorry.
Do you need permission from both networks to build a bridge?
No, you don't. You can.
Anybody can build
Yeah,
it.
anybody can build it if you make it work, right?
Oh.
Yeah.
Okay, then the next question is that if I'm an entity with credibility, if I go and build a bridge and connect everybody, then I get to unify all the chain, right?
That's gonna be a really.
Do people trust it?
Yeah, and that's going to be a huge engineering project because you're going to have different communication protocols, and it's almost impossible unless you just behave like a central exchange, right? Like a
This-
normal
let's
exchange.
say if I'm Swift, which is the
Yeah,
entity,
yeah,
right? I
yeah.
could invest and connect,
Yeah,
build all the bridges, and then people trust me because of me. Then I get to control all the. I'm just because I mentioned the bad guy, right?
It's already done. It's called Binance.com.
but
It's already done.
it's a centralized entity, so it's different from Swift, for example. It's not a universal communication protocol, for example. Yeah, I would say.
I mean, what I'm saying, isn't
Yeah.
this a vulnerability for the whole chain, right?
It's going to be very difficult. I would say it's possible, but I mean, even if you incorporate few chains, it's still a huge engineering project. Yeah. Especially like a lot of the infrastructure like down there is very different, and you have to consider the safety as well, right? Yeah. So I did participate like last year's DeFi summit in Stanford, and we talked about bridge security, and the guy was saying that for bridge you always have a balance of assets. So for example, when you lock and mint, when you use the lock and mint model, you lock in certain assets and you mint assets on the other side. So there's always a way that you can audit the balance. And when hackers conduct attacks, for example, they use forged signatures, they withdraw assets, then the balance will be changed, right? So something like formal verification system, like before the bridge operation and after the bridge operation, if certain properties have changed in an unexpected way, then the emergency procedures can be activated. For example, halt the bridge, and the attackers will not have enough time to withdraw the assets. So for example, the grace period for a lot of private entity bridges is almost like 48 hours. So it's still plenty of time for developers to pause their chain before attackers can withdraw their assets. And that could be a standard in the future for other bridge providers to have this mechanism that they will make sure that their assets don't go out of balance. So for example, in a wormhole attack, attackers didn't deposit synthetic Ethereum, but they got Ethereum on the other side. So there's an imbalance of assets. The vault didn't receive the total number of Ethereum just decreased, did not increase. So it's possible that it could be caught using this mechanism.
Automatic circuit breaker. So
Yes.
there's limits. So there's a huge withdrawal.
Yes.
Then you can put a circuit breaker.
Yeah.
And
That's another pattern that you can use.
Then you can stop the
Yeah.
attack.
Yeah. So if
Anyone has thought about that yet?
uh,
Automated circuit breaker.
Yeah, I think some bridge providers, they are actually researching on it and trying to implement them.
Well, I assume there must be like common attacks on all these different types of bridges, and there must be either ways that they can monitor for the vulnerability to allow that to happen, or actually detect when it happens. I assume they must be doing that now, right?
Yeah, yeah.
They must have teams of people doing this.
Yeah.
24/7.
Yeah, so right now it's because all the incidents, right? So people really were talking about security and like, yeah, investing everything.
So when you talk about the coins being locked, right?
Yeah.
How does that work technically? Like, is it like with private keys that's held by the breach operator?
It's usually by a smart contract.
Oh, I
So
see.
yeah, so basically it's like a vault. You deposit asset in there, and nobody can withdraw technically. Only if it's like a multi-signature address that they can do the emergency withdrawal, or if the contract receive a signature confirmation that on the other side the assets has been deposited back, so they can release the asset. So it's basically performed by smart contracts, the lock mechanism. So this is the validation model. The lock and mint model requires cross-chain bridge to carry contracts between different chains to complete lock and mint operations and to receive events for single or multi-point verification. The lock information on chain need to be captured legally verified. Then mint credentials can be issued for signatures, which can be withdrawn or directly issued by the user on the B chain. So when user A call lock on A chain and deposit Ethereum, Ethereum will be locked, and this smart contract will emit a custom event, a lock event, and will be picked up by validators, and that could be nodes that they operate. It could be POS or could be POW. So it will be picked up by the validators, and validators will issue a multi-signature to B chain, and B chain smart contract receive the signature and can call mint to give user B, or could be the same person, it doesn't matter, but we give the user on the other chain the packed Ethereum, that is a synthetic Ethereum. Any questions on this model? So take the example of this cross-chain bridge on BNB chain. There are two main methods of lock. There's cross-transfer and cross-transfer native. So we're looking at a cross-transfer function here. They require cross-chain ERC20 and native related tokens to be transferred to this contract to lock the crypto assets on that chain. So first we have this request statement that makes sure that this token transfer is successful. And then we emit this event that signals the cross-transfer has occurred with the amount. And this one is for the native assets. So this one, we use the ERC20, we ask the token to transfer it, but this one is native, so we actually see if the message.value is bigger than 0. And if it is, then we will know that people transferred in native assets to try to get another asset on another blockchain. In addition to this, a copy of the same contract exists on top of the target blockchain, and the main mint method is mint transaction. So in the mint transaction, we require this event, and then if it's native, then we will transfer this amount directly. If it's non-native, then we will have this token, like another synthetic token, be transferred to the target address. And of course, the signature needs to be verified properly.
When you say it's not native, you mean you've got one synthetic and you're moving that wire route to another chain. So you're moving a synthetic as opposed to a proper token. You're moving it. Is that what you're saying when you say?
So for example, a token, ERC token, you transfer that to this lock and mint model. For example, AAVE token. and you logged in there. And on the other side, another contract has to mint synthetic tokens to you.
Correct.
So that's synthesized by this operator.
Yeah.
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 What's the difference between the lock and burn? I think that's the question.
The lock and what?
Burn.
Burn. So the synthetic token, if the user on the other blockchain wants to transfer the assets back to the original blockchain, previous one, he would transfer the synthetic token back to the smart contract, and the smart contract will burn it and have the signal emitted and picked up by the validators. And basically, it's the opposite. So we'll pick up by validators, and validator will send an event to A chain, and A chain will unlock it and get the original assets back to the user on the other side.
Do you have to use the same bridge to convert back, or can you use different bridges?
You have to use the same bridge.
Okay. What happens if when you've minted the synthetic, if you want to move that synthetic to another chain?
Yeah.
Can you move a synthetic, or do you have to go back to the original chain and then use that original token or whatever to go to that other chain? You know what I mean?
Yes, depends on the bridges. Some of them they have this function, and some of them don't. It depends on what chain they support.
Okay.
Yeah.
So some bridges will support
Yes.
basically
Yes.
moving synthetic tokens across.
Yeah.
Okay. Interesting. Cool.
So this is a liquidity provider's validation model. So take O3 interchange V2 as an example. This protocol achieves asset swap by deploying swap contracts on both chains and uses USDC and PUSDC, AMM pools for intermediate cross-chain asset management, and PTMC, Pack Token Management Contract Protocol, to achieve liquidity swap and cross-chain purposes. So as we can see here on the Ethereum mainnet, there's a O3 aggregator, and then we're trying to deposit in like Ethereum, and this DEX, the AMM pool, will actually be converted to USDC. And so the user's intent is to get Ethereum from Ethereum network to USDC on the BSC network. And the path he will go through is like this. Ethereum will be converted to USDC through a DEX, and then the DEX, the USDC will be put into this USDC PUSDC MM pool. PUSDC is basically created by this O3 inter-exchange. And when you burn PUSDC here, you can mint PUSDC on the other side, the BSC part, and this way the users on the BNB chain can get USDC on the BSC chain, and he can also use this DEX to transfer it to a USDC or to a BSC. So native assets to native assets, but the internal process is very complex. Any questions? So, yeah.
So the USDC is like a bridge, kind of.
Yeah, yeah.
For these two, okay.
So basically, this exchange uses USDC as an intermediary,
Got it.
and the PUSDC is the asset that's issued by themselves.
Great.
This is the XCM model built by Polkadot, and this is for substrate native chains only. It's a bridging palette is used, and the underlying bridging palette relies on cross consensus message format, XCM. It is Polkadot's cross-chain messaging protocol that allows a parallel chain to send message to another parallel chain and provides guarantees for the delivery of these messages. The cross-chain messages are not delivered to the relay chain, but the collaterals node is responsible for routing the message from chain to chain. So as we can see that because it is both chains are substrate native, they can have this internal communication channel that enables the communication between this relay chain and this parachain through validators and correlators, which is not the privilege that other chains will enjoy when they are doing bridges between them.
So are any other blockchain language companies like Polkadot starting to build their own kind of equivalent of the XCM
Yeah.
of theirs? Because it sounds like it's a competitive advantage for Polkadot, right?
Yes, for substrate-based chains, it is an advantage, but for other companies, I'm not aware of they're doing that.
Okay.
Yeah, because Polydot, I think they envision a different ecosystem. I think they encourage different functions to be put on different chains.
Yeah.
Yeah.
Okay, understand.
Cross-chain bridge validation model. Step one, user invokes a smart contract on parallel chain A to initialize a cross-chain message, which is destined for parallel chain B. So that's the first step. And the second step, the collector on parallel chain A, that's the one that specializes in collecting on-chain message, will place the message on the exit message queue of parallel chain A. So they put the message here on the message queue. And third step, the collector on parallel chain B will find this message whose destination is parallel chain B and put the message on the entry queue of parallel chain B. So similar to that. And the steps will performed by the collectors and validators. Validators of both parallel chain A and parallel chain B validate this message. The collector of parallel chain B processes the message in constructing the new block and therefore runs the smart contract in the message to complete the asset transfer. The smart contract locates on the chain B, and it will basically use this message and to complete the asset transfer on chain B. The validator of parallel chain B verifies that message has indeed been processed without any problems and writes the block to the relay chain. And relay chain actually has this history information of the cross-chain transfers. So atomic swaps. Atomic swap, as we mentioned before, it needs both chains to have the same hash algorithm. And that's the case with Bitcoin and Bitcoin Cash. So we'll use Bitcoin and Bitcoin Cash as examples of how the atomic swap implementation works. It is based on two hash time lock contracts, also known as HTCL. The blockchain is like a pile of locked mailbox cabinets with deposit slots that correspond to blocks on the chain and transaction data within the block. When you want to receive Bitcoin from someone, you tell them which mailbox to put the coins in and the corresponding contract to look up the transaction data. So in one transaction, suppose Bob wants to pay 0.5 Bitcoin to Alice, and he put 0.5 Bitcoin into the slot of mailbox A, into one of those mailboxes, which is locked by lock A. When Alice is ready to spend the coin or transfer it elsewhere, she uses her key A to open the lock and remove the coin. So if Alice wants to use this lock, but in the cross-chain bridge I think it's Bob transferred to Bob himself, but he still uses this lock to transfer assets. In a two-way transaction, Bob pays 0.5 BTC and expects to receive 1 Bitcoin Cash from Alice. The contract deployed on both chains to accomplish this is the hash time lock contract. So in this two-way transaction, he will get 1 Bitcoin Cash from Alice. And in most cases, it will be the two-way transaction because the values are different of usually, even they have the same hash algorithm. Yeah, the difficult part would be to have the hash time lock contract, and that's why they need to have the same hash algorithm. Otherwise, the keys will not work to open those mailboxes. So yeah, let's talk about Mixer. So why did Mixer exist? The transaction of crypto asset is publicly available on-chain, and as long as one knows the address, all the on-chain operations are clearly visible and traceable. In this case, to address the issues of privacy and anonymity, the Mixer technology was born. Yeah, so as we can see, there's a funny picture of before mixing and after mixing. But even in BTC, there are mixers. Principle of Mixer. Mixer is a decentralized privacy feature that allows users to quickly and efficiently mix with other users' funds, creating a random mapping relationship between existing user account and new accounts after coin mixing. The role of Mixer is to integrate a number of people and transactions that are not related to each other into a single transaction. At this point, it is not known from other which input transaction should correspond to which output transaction. So just a quick question. Like how many mixers do you know that exist nowadays?
2.
What are they?
Tornado Cash.
Yeah.
The other one I can't remember. Was the second popular one?
Tornado Cash and you mean in Ethereum or in other blockchain?
Ethereum. The second one I can't remember, but there's another quite well-known one.
I think in Ethereum they still use Tornado Cash a lot. So yeah.
It's being sanctioned, so they come up with another one, which is also getting popularity.
Oh yes, it's like there's AZ network. AZ. So yeah. So yeah, that's basically a different layer. So it's different than Tornado. Aztec. So yeah. I think. Yeah. And yeah, in Bitcoin there's like a Samurai wallet and Wasabi wallet that they do coin join to mix, and there's also some other mixers that exist. So yeah, let's keep going. A lot of the mixers are actually centralized, so they're operated by some entities. For example, last year, I think FBI took down a Bitcoin mixer that served for a lot of cyber criminals in Russia. So yeah, all transactions are processed within the database of the mixer. The mixer matches different wallet address and different amounts and sends a random amount of token to the address until total amount requested by the sender is reached at a specific address. So yeah. So this mixer operator is receiving coins, and then basically mix coins and send random amounts to obfuscate the transaction. And you need to trust people who operate this mixer. This is a model of decentralized mixer. Decentralized mixers use protocols like CoinJoin to mix transactions using a fully coordinated or P2P approach. Essentially, the protocol allows a large group of users to aggregate a certain amount of cryptocurrency, utilize the UTXO feature, and then redistribute it so that everyone receives a certain amount of cryptocurrency. However, no one knows who has received or where it came from. So we see inputs like that, and I think the 0, 1 at the end is just the transaction fee, and then we got different outputs. So if we have the input and output the same amount, and then we don't know who actually sent those coins and who received it. So that's the purpose of Mixer. So we're going to introduce Tornado Cash, which is the most infamous mixer in Ethereum. Tornado Cash is a decentralized, non-custodial privacy solution based on zk-SNARK technology. it can improve transaction privacy by breaking the on-chain connection between the source address, depositor, and the target address withdrawer. So the Tornado Cash works by, if you deposit 100 Ethereum to this Tornado Cash address, they will give you a signature, a hash signature. And after a certain period of time, you can redeem using this signature and have the Ethereum to be sent to another address, to a new address, unrelated address. And therefore, this whole mixing process is done. Right now, you can't access the Tornado website anymore, but the smart contract is still free to access. The inferrer node, which is the default node operator in MetaMask, also blocked Tornado Cash. So if you want to access Tornado Cash, you have to use different node operator. You can set the RPC provider in the MetaMask option. Or if you want to use the website, you can use the IPFS version of it. It's really slow. But if you're a US citizen, I don't recommend because you might get into legal problems. Yeah.
So I'm still trying to figure out why would people want to mix their cryptocurrency? Because it sounds like only money launderers want to do this.
Yeah.
Is there a use case for legitimate institutions to want to mix their currency?
Some people want to protect their privacy, and for like, yeah, it's basically, but almost like, for example, Tornado Cash was used like 80 to 90%. The sheer amount was 80 to 90% value used by criminals. So the rest 10%, they might have legitimate concerns about their privacy.
And I'm looking at the structure of a block and a blockchain. All it does, it says which user sent the currency and which user received it or which wallet address.
Yeah.
And the amount. So actually the block doesn't care about the units, as in the units are fungible. You can swap the units. It doesn't
Yes.
care. It just cares this wallet
Yeah.
at 100 BTC,
Yes.
for example, but it doesn't care what units.
Yeah.
So if we use Tornado Cash or mix Sui, what happens to Sui? Because Sui is object-oriented, right? It
Yeah.
tracks by object. So once we mix Sui, does it mean that ownership of the Sui is also mixed?
There's no mixer for Sui
there's no
yet.
mixer for Sui.
Yeah, it's still in test. It's still in DevNet mode, testnet. So, in terms of Sui, I think a potentially model would be to for example, because the object model in Sui is so unique, you have to transfer the ownership of this object.
Sui
So,
coin.
yeah. So you have to give up your ownership to a central party mixer, yeah, which you have to trust them, and that is very difficult unless they implement something like Tornado Cash. In Tornado Cash, yes, you actually transfer your assets to this Tornado Cash mixer, but the ZK Snark protocol actually ensures that you can receive your money.
Right.
Yeah.
Is Tornado Cash open sourced?
It is open sourced.
Then why do you need the ZK Snark technology to ensure you can receive your money back? If it's open source, the logic should ensure that it comes back, right? Even without ZK Snark.
Yeah, but if it comes back to your original address, there's no point. You're withdrawing to a different, complete new address.
Okay.
Yeah.
It will ensure that it goes to a different address.
Yes.
I see.
Or you can use a different address to withdraw. Of course, you can use your original address to withdraw. That's the wrong usage of Tornado Cash, though.
I see.
Yeah. So Tornado Cash uses a smart contract to accept token deposits from one address, then withdraws the funds with a brand new address. Older versions of protocol available on Ethereum, BNB chain, Polygon, Genesis chain, Avalanche, Optimism, and Arbitrum. Yeah, so actually, only on Ethereum and BNB chain, it has some volumes. So if Tornado Cash Pool, a brand new one, not many people are using it, it's impossible to mix. The more people use it, the better the mixing effect is. So that's why on other chains, not many people use them, so it's almost dead. So yeah, this is the old website. Before it looks like that. So you deposit first and you withdraw. User will first need to transfer the asset to Tornado Cash smart contract, where Tornado Cash gives the user randomly generated keys as a proof that you have executed the deposit without revealing the original address. To withdraw it, simply submit the random key previously given by the system. Once the user submits a new address, the smart contract transfers the asset to the new address and completes the mixing of the assets so that the transaction cannot be traced. True and not all true, because the transaction can be traced sometimes. Some inexperienced user deposit and withdraw in a really short time frame and with very unique amount, for example, 100 Ethereum. Not many people have 100 Ethereum. So if someone deposit 100 and withdraw within 5 minutes, that's likely the same person. Or if the amount was have some patterns, for example, I have 130 Ethereum, and I deposit all of them to Tornado Cash, and I withdraw on the other side with a brand new address, but withdraw 130. So this number actually correlates, and that's another way to tell who used the Tornado Cash. And there's some other ways. For example, use artificial intelligence to analyze the address activity. If this address interact with certain DEXs or certain, like for example, gaming apps, and some newly created Tornado Cash address have the similar activity, then we can infer that might be the same entity.
When you say fixed amount, it's a multiple different fixed amount.
Yeah, so it could be 0.1, it could be 1, it could be 10, it could be 100.
Oh.
Yeah. But those amount can be set in your smart contract. It doesn't matter. So it's just the one that's used by Tornado Cash. If you modify the source code, of course you have different amounts.
Yeah.
I'm sorry, for dusting tokens that act as tracing tokens, if we put it into a mixer, will it still retain its tracing feature or will it get mixed? Can people still track the path of the dust?
Dust? Dust is a very small unit. So when you deposit to Tornado Cash, you have to deposit fixed amount. So either it's 100, 10, or 0.1 or 1. Okay. So dust will not be transferred to Tornado Cash.
Okay, because I was just thinking, wallets may get dusted and we're not supposed to touch the dusting amount.
Yeah.
But can we clean the dusting amount by putting it in the
No, because dust amount is too small. And also dust exists in Bitcoin, the Bitcoin network. This one works for Ethereum. Yeah. But same, like if it's too small, you cannot transfer to the Tornado Cash. Because nobody is withdrawing and depositing that small amount. The gas fees are higher than the value itself.
Okay.
Sorry, one more.
Yeah.
Does Tornado Cash allows you to split the original asset amount? Like you put in like 100,
Yeah.
and then I want it in 10 tens. I mean split to 10 tens instead of drawing 100 again. For example, I'm putting 100 Ethereum, right?
Yeah.
And then I want the receipt to be 10 pieces of 10 Ethereum. Does it allow that function? Or it has to be, I'm putting 100 and then the withdrawal is 100.
I think it has to be the same amount. Yeah.
So in that way, then it will be even less easier traceable, right? You can split the amount.
Yes, unless you actually aggregate them to one address later. Yeah, because the signature can only be used once, right? So, yeah.
Yeah, there's another term I heard is PII, personal identifier information,
Yeah.
which is embedded if you transfer more than 1,000 USDT value.
Yeah.
So if I use Tornado Cash, will the PII information attached to the address or
Who's trying to get PI information?
is the protocol itself that
Yeah.
embedded into the cryptocurrency?
Yeah.
So the PII information also attached, or is it split at the thing? I'm
Sorry.
not very sure yet, that's why I asked. So people use the Tornado Cash, but
Yeah.
it still can be traceable in the end.
Sorry, I don't get the question. Can you
Okay,
repeat it? Can you repeat it? It's fine. It's fine. It's fine. I mean, like, I can repeat it if you want.
Sorry.
Like, what was the question?
I mean, like, even if I use Tornado Cash,
Yeah.
the PII information is embedded.
Yeah.
It should be traceable, right?
I mean, if you use a completely new address, then you don't have that information attached anymore.
Okay.
Yeah. Yeah, but some smart contract will actually like flag addresses coming from Tornado. For example, I think DYDX, they don't allow like USDC from Tornadoes. and some other exchanges they will ban you if you use tornado cache address. Yeah. So yeah, so this is the end of this mixer bridge lecture. Yeah, I'm kind of sad that bridge incidents were not involved in this lecture. Yeah, but anyone what is the bridge hack that you mostly want to know that happened recently? Binance? So yeah, so Binance hacks actually happened because of the pre-compiled library problem. And the story goes like that. For basically, the hacker paid 100 BNB to be in a node in order to relay messages. One important part is you need to relay messages, right? And then he basically put in collateral and relay messages, and he used a signature from way back a long time ago. And then basically, because the IAVL cheat verification code has problem, and that's not the problem of Binance. All Cosmos related chains had that problem. It's the problem of Cosmos SDK. But Binance Bridge was built a long time ago, and they did not have any emergency protocols to stop it or to audit this balance, and that's why the hackers minted over I think over 10 billion USD amount of BNB, but of course they didn't cash it out. Some of them got frozen. Yeah, so that's the problem of a precompiled library that sits on the address 0, the signature verification function. Yeah. So yeah, that's almost ranked the second largest hack, but the hacker could have got more. He just didn't cash out. He couldn't, because it's too huge. Even the entire BNB chain was paused.
So does it mean there's no way to fix it? Because you said the library sits on the chain.
Yeah.
Address 0.
Yeah.
So there's no way to fix it.
Yeah, precompiled library is built. It sits on the contract, right? The 0 contract.
Yes.
So if Binance control the chain, then of course they can redeploy it, but they simply disabled it. So I think even then they cannot modify this precompiled library. So they disabled it and used other libraries to verify signature afterwards. Yeah, the contract is not fixed, still on the chain.
So when you say that they use a very old signature, can you elaborate on what's the problem with the signature?
Okay, so